Now that we've looked at a few different examples of synthetic division, we can focus on a little more complicated version. This time, our linear term is not just of the form x equals something. It's 4x minus 5 in this case. Just like before, we'll go ahead and start by writing our coefficients in order, making sure we don't miss any. So we have x cubed, x squared, x, and then x to the 0, or no variable. Before, we set the denominator equal to 0 to let us know what we were going to synthetically divide by. And we'll do that exact same thing again. So this time we get a fraction, 5/4. And while our multiplication is a little more difficult, it all works out just like before. All right, so we may be tempted to just go ahead and say our answer is and we would be almost right. But we have this issue. We actually divided by 5/4. We divided by the factor x minus 5/4. So to fix that at the end, we actually need to divide this by that part that we skipped out, in this case of 4. So we get 8x squared minus 2x minus 15 plus that remainder. Now, it may feel weird that the remainder is going to stay the same, but that's because when we would plug in 5/4 into this equation, we would get 2. So this remainder isn't affected by us doing this little trick so that we could do synthetic division. Only our quotient is affected. And this feels more right. If we had just looked at these first two terms and we had looked at 32x cubed minus 4x, we would have said, hey, we should have gotten 8x squared. So that's that little reminder, that little hint. You can always divide your first two terms to figure out what should your quotient start with. What should it look like?